Can we see? Yeah? Okay. Now, you'll need to read the question to me so I can have the info, please.
Mass 3, a mass of 3 kg of the spring simple harmonic motion of amplitude 2.5 centimeters at a frequency of 1.5 hertz.
What was the mass? 3, was it?
Yeah.
Okay.
Determine the maximum velocity of the oscillator.
I assume you got that okay.
Yeah.
So what's the problem with B? What do they want?
Sketch a graph of kinetic energy against one full cycle of the oscillator.
Say that, I can't hear you. Sketch kinetic energy.
A graph of kinetic energy against time for one full cycle of this oscillator.
Now, do we know if the motion begins on the inside or the outside? How do they set it up? Does somebody pull the spring back? I mean, what? They didn't say?
Executes simple harmonic motion of amplitude 2.5 centimeters.
That's all the background info?
Yeah.
Yeah, so this regardless of his
Regardless of what?
case.
Of what? Yeah. Phase?
Can do it.
Ah, okay. So what they're saying is they'll accept both answers if you have it start at the inside or the outside. Let's have it start at the outside. So what's the kinetic energy if it starts on the outside? 0. Okay. Then it will reach a maximum. It will slow down, and then it will stop at the other side. Now that's not one full cycle though. That's only half a cycle. Then it has to go back to the start. So that's 2 cycles.
It doesn't go down.
Well, I don't know if they want you to consider damping. In real life, it would be like this. You know?
Oh, I know what's right.
But I'll just draw it like this. An M shape. Okay? Is that okay? Yeah. Okay, so that's why they must have had you get the V earlier. You have to get the kinetic energy here. What was the V, Bello? 236 meters per second. So if you get the kinetic energy a half mv squared, then what do you get? Point. Say again? 0.027 joules, is it? 0.278. Okay. Okay. Right.
My question was not damping. Like the first example we got on the harmonic motion, like we went up and it goes to also the.
Yeah, but Bello, what was that a graph of? That wasn't a graph of kinetic energy. What was on the y-axis? Displacement or velocity or acceleration? Did you see the graph for kinetic energy that we have in the notes?
Yeah.
It's a quadratic shape. Yeah. What's next? Tree B? Yeah, what tree? 3 and 4.
No, we
Like Roman figure 4.
Okay, which question are we looking at?
number 3
Number 3, which part?
before the last
Okay, the last part in it, right. What did they ask in that part?
Determine the shortest time taken for the tip of the rope to move from a position of 20 millimeters below the equilibrium position to a position 20 millimeters above.
Okay, okay. Was this a question where something was pulled down?
Yeah.
Yes.
Okay, so what was the info? It was pulled down how far, or what do you know?
Should I just read this?
Yeah, give us the background info. What's happening?
The steel rope is clamped to the end of the bench so that part of its length overhangs. The overhanging part is pulled down and released so that it vibrates with simple harmonic motion with a frequency of 5 Hz.
Okay. So that goes up and down. Yeah. Do you know the amplitude? Do you know how far down it's pulled? Okay. What else are you told?
Determine the time period of the vibration.
Okay, fine. What else?
Determine the maximum velocity of the tip of the hole if its amplitude of vibration is 35 millimeters.
There we go. Okay, so the amplitude now is 35 millimeters, is it? Yeah. And then next?
Determine the maximum
Acceleration. Okay. Okay, I think I have all the info now. So, they pulled this ruler down, didn't they?
Yeah.
And they caused it to vibrate up and down. So if you just look at the motion here at the end, what's happening here? Here's the center. It begins here. It'll go up and down, up and down, up and down like this, right? So at the beginning, its amplitude is 35 millimeters. It will go up, and we want it at the distance of, what did they say, 20.
20.
And then we want to know the time it takes to get to plus 20. And then we can subtract the two to get the time it takes to go from here up to here. Okay? So, let's see. I will have to use cos or sine.
Sign.
No, cos. Because it starts on the outside. Remember, O for outside, I for inside.
That's why I thought about it. Their own solution is to use sign.
Right, well then, am I missing something? I thought they said it's pulled down and released.
Yes. Yes.
Yeah? And released. And nothing happened in between, did it? Actually, you know what, David, can you just read the last question? What did they say?
Determine the shortest time taken for the tip of the rope to move from a position of 20 millimeters below the equilibrium position to a position 20 millimeters above the equilibrium position if the amplitude of the tip of the rope is still 35 millimeters.
Okay. I suppose you could use sine, but it just seems a lot harder. The easiest thing to me would be to use cos. Okay? So it starts here and it moves up. And then it continues moving up. And we want these two times. If we minus them, we get the answer. So I'll call this positive and this is negative. So x equals a cos omega t. Now you can have omega from earlier in the question. Okay? Yeah. So what's the value of x here? That is, x is 20 millimeters. And when it's here, minus 20 is on the other side. So first we'll solve this equation. 20 equals the x. Now, do you know what the omega is? You could work it out, couldn't you?
Yeah.
Now, in your calculator in radian modes, what did you get here for the t? You can let me know when you're ready. 1.11, is it? Did you have the omega?
Yeah, the omega is 2 pi over 0.2.
2 pi over 0.2, isn't it? So what's that? 31.4. 1, yeah, okay. Right, so that's the time. Now, do the same thing, except this time put in a minus 20. What do you get? The omega is 31.4. Got it? I was expecting it to be bigger than the last answer. Do you get a time here, guys? Abdulali, did you get a time? Okay, come on. Come on, guys. It shouldn't take you too long to do this one. It's easy peasy. Come on. What's the time? Son, come on. I want the time here. Give me the tea. Oh my goodness, I'm going to start getting angry. What is taking so long? What is the time? It is a negative, is it? Are you in radian mode?
I think it's 2.96.
You need to be in radian mode on the calculator.
I think it's 2.96.
That sounds more believable. Are you in radian mode?
How many genes do we have?
Oh.
Calculator is just like
No, 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 no. Oh my goodness. Oh my goodness. This might be wrong, so. Guys. Guys. Marvon, look at me. Look at me. You need to put your calculator in radian mode. There should be a little or on the top if it's in radian mode. I don't know how to do it on your calculator. You know, try shift mode. Yeah? Setup mode, something like this.
you've seen them before.
Oh, come on, guys. This is painful. What's taking so long? Do you have it, Dami? Aoife. Ming. Do you have the time? The tea? Ah, guys. Guys. What is the matter with you today? Right, what's the second one? Minus? No. Okay, you think it's 1.756. And the second one? Right, let me confirm the first one here. Actually, hang on. Mode, look guys, look. Shift, mode, radians. Not 1.756.
But you put 20 over 35,
that is the same number as 20 over 35. I got this as the first one. 0.0306. Now let me get the second one. It'll be minus 20 divided by 35, right? Shift cos inverse, and then divided by the omega. 0.0694. And now minus 0.0306, 0.0388. That's my answer. Yeah, but what answer did they get?
They got 1.11.
They got what?
1.1.
No, they're telling me they got the same answer. They got this answer. Okay. And was it longer? Was it harder? Similar. Now the reason for this is because I'm using cos because it started on the outside. You should use sine when it starts on the inside. However, you get the same answer if your question is what is the difference between two points in motion. Okay? So for example, if I said when will it be at 20 millimeters and when will it be at minus 20 millimeters, my answer is right, their answer is wrong. However, we both get the right answer when we subtract the two times to get the time in between. Okay? Now I can give you a simple explanation for that. If I said to you, compare to me how far away is Sun and how far away is Aoife, that will give you one answer. Okay? If you said compare to me how far away is Sun and how far away is Aoife, and you use bellow, then you'll get two different distances, won't you? So you get a different answer. However, we'll both have the same answer to the question how far apart are Sun and Aoife, this distance here. Okay, that's kind of what's happening here. They're using sine. They're getting the wrong times, T1 and T2. However, the difference between the two will be right. And so that's why they get the same answer. So I don't like that they use sine. I would have preferred that they used cos. But it doesn't affect the final answer. Okay. We shall continue though. Okay.